Let us discuss initial tension in the bell. While transmitting power by bell, it is assumed that the total length of the bell remains unchanged. The bell material is elastic. This is considered as theoretical assumption, but practically this is something different. Now, a belt is fitted on the pulleys is having some tension, because of which it can run continuously over the pulleys. This tension is known as initial tension and it is denoted by T naught. মানে কি হল বেল্ট এডাল যেতিয়া বেল্ট ড্ৰাইভত আমি ফিট কৰোঁ তেতিয়া কি হ'ল ইনিচিয়েলি the belt drive tends to move মানে অলপ মুভ কৰিব বিচাৰে. So that is due to initial tension. Now let us consider T1 tension in the belt on tight side, T2 tension in the belt on the slack side. Increase in tension on the tight side is T1 minus T naught. Increase hoise tight side. Decrease in the tension on the slack side will be T naught minus T2. If tension is increasing on the tight side, the tension will decrease on the slack side. So these are the expressions. But as per assumption, stress of the belt on the tight side will be equal to extension on slack side. In the next step, strain on tight side will be equal to strain on slack side. Next step, stress increase on tight side will be equal to stress decrease on slack side. Now if you remember, stress is force per unit area. So increase in tension on the tight side, that is given by T1 minus T naught, will be equal to decrease in tension on the slack side. So this tension increase or decrease, these tensions are in that means are a kind of force, and these are per unit area. So the expression will be for T naught is equal to T1 plus T2 divided by 2. If you consider the centrifugal tension, then it will be T1 plus T2 plus twice Tc divided by 2. মানে কি হ'ল stress increase on tight side will be equal to stress decrease on the slack side. Stress মানে হ'ল force per unit area আৰু force per unit area, tension to হ'ল a kind of force. So increase in tension on the tight side per unit area will be equal to decrease in tension on the slack side per unit area. So এইটো এক্সপ্ৰেশ্যনৰ পৰা আমি ইনিচিয়েল টেনশ্যন টি নটটো পাই যাম. টি নটটো তেতিয়া হ'ব T1 plus T2 divided by 2 উইদাউট এনি চেণ্ট্ৰিফিউগেল টেনশ্যন. যদি আমি চেণ্ট্ৰিফিউগেল টেনশ্যন কনচিডাৰ কৰোঁ তাতে টুৱাইছ Tc2 প্লাছ হৈ যাব. There is an expression which is required for designing of a belt. So this expression is sigma T tensile stress in the belt, it is in Newton per meter square. Small t thickness of the belt in meter, small b width of the belt in meter, capital T maximum tension to which the belt can be subjected. So this will be T will be equal to, that means maximum tension in the belt drive will be equal to sigma T b into T. Sigma T is the tensile stress and b into T is the cross section. So if you multiply stress with cross section, you get the tension, maximum tension on the belt drive. If you consider the centrifugal tension Tc, it will be T1 plus Tc, that is the maximum tension in any kind of belt drive will be always tension on the tight side plus the centrifugal tension, so that is T. So it will be equal to sigma T into cross section area, which is b into small t. This expression is useful in the design of the belt drive.